Hello, good day, good morning, good evening to everybody. Welcome to this webinar about building 2D meshes fast with an online tool. My name is Thomas. I'm the global product specialist for Mic Plus Pipeflow here in Vienna. So it's quite dense for 45 minutes or so. Short introduction, and then I'll show you live how to upload data, create the first 2D mesh. We'll look at simplifying buildings, because this is, at least for the urban, quite an important task. We extract and buffer roads from OpenStreetMap, create a second mesh, including those roads, interpolate elevation, and I'll show you at the end a bit how to insert a second DM on slides only, and how to handle rivers with cross sections. First, a short introduction. I mean, this is a Mic Plus webinar, and at the other hand, we talk about an online tool, and this online tool is the Mic Mesh Builder. So how are those two connected? We have in our desktop products the desktop mesh generator. First of all, in the Mic Zero products, and those of you who have worked with Mic software for a long time might know these tools. It has various aspects, various windows. What you see here are just two of them. On the left-hand side, the mesh editing mode, and on the right-hand side, the arc editing mode. And there are several others, several other tools as well, which are available in Mic Zero. And in Mic Plus, we have implemented the same technology in the background. We've just made it a bit easier to use, I would say. So if you open in Mic Plus the 2D domain editor, it has two tabs. One is for the domain, where we set up the mesh, including holes and whatever it is. And it has a second tab for the interpolation of elevations. And when we do that, afterwards we can color our mesh and show the isolines and things like that. And both Mic Zero and Mic Plus use the same technology in the background, the so-called mesh generator. But this mesh generator has sort of become slightly outdated, and DHI has, a couple of years ago, decided to create something new, web browser based, so cloud based, which is available for more than one product. So this is the promise, or Mic Mesh Builder in two sentences. Mic Mesh Builder is a web-based tool for creating high-quality 2D meshes for riverine, coastal, and urban flood applications. And indeed, it's used in all three areas of expertise. It avoids time-consuming errors in data preparation by automating and documenting workflows. And let's see whether we can keep this promise. There is documentation available online. Here is the URL to access the documentation. First of all, we have the Mic Cloud administration. You'll see in a second. And I want to mention that this PDF file here is, I find, easier to read than the online help. And the same goes for the Mic Mesh Builder documentation. We've also various videos on YouTube. And if you open the Mesh Builder, you'll see on the right-hand side this question mark, and it'll drop down again. You'll find supporting documents right online. We start with uploading data. We are talking about two web applications, really. One is the Mic Cloud administration. And here you upload data. Here's the icon, here's the name. Here you upload data. Each company, I'm working with DHI, can create several folders, and each folder is more or less for one region where you upload the elevation models and whatever it is you need in that area. And then you would, if you work somewhere else, you would create another folder. So this is the folder structure. And the second application is the Mike Mesh Builder. Again, I'm here in my company, in my folder, and within this folder, I can have several mesh builder workspaces where I create meshes. So it's a one company, several folders, and in each folder, several workspaces. And let's go directly into the browser interface. So this is the Mike Cloud Admin. I've created already a folder here, and I've already uploaded building footprints and a digital elevation model. And one is a raster file and one is a vector file. What I want to add now is the outline of our mesh. Usually when we upload, we want to add some information. First of all, I can rename the whole thing, and I name it simply to the extent number 4. I convert from shapefile. I still have to tell the data, my cloud admin, what I upload, and I want to convert that to GIS vector data. And very important, we have to define the projection or the coordinate reference system to be more precise. This one has the code 2193 because the whole setup is in New Zealand. I usually write the coordinate reference system in the name of the zip file, so I don't have to think about that when I upload. Uploading may take a couple of seconds, or with a large data set, even a couple of minutes. And from the My Cloud Admin, I can open the Mesh Builder. Now, back in the Cloud Admin, you see that this has been uploaded, sorry. And I've already prepared one workspace. I could create a new one, but I've already created one. So I open this workspace, and you see that this workspace contains a background map. We are here in our, you may know this Blue Beach or Red Beach tutorial area. We use a lot in our tutorials. We see the building footprints, and I've already uploaded a digital elevation model here. And now I want to add the outline of our mesh. So I click here on this tool, copy from platform, and now I look into this folder and I say, okay, I want to add this data set. And the same way you would add any other data sets, like point clouds or shape files with rivers or whatever it is. I want to add it as a geometry. Well, this is the only thing which does really make sense. Yeah, this is the user interface, by the way. I didn't really explain it. So yeah, here you have the map. Here are various tools, well, mostly zoom and measure and things like that. And on the right-hand side, we'll have the source data and the meshes and all the operations. So this is more or less the command and control. The extent has been added. So this is the area where we want to mesh. Let me quickly check my notes whether I forget anything. No, so that's where we want to start. And we simply start here by creating a new mesh. Up here would be the meshes. We create a new mesh. We want to include the outline, and the buildings. And I forgot to Well, there are two ways, and it really depends on your modeling task how you include these buildings. One way is you exclude the buildings, so there are holes in your mesh. This is typically done when you run a coupled model and the roofs are connected to the sewer system directly. Or you could keep them in the model in the 2D surface, but you would apply, we call them infrastructures, to the roofs so that the water flows from the roofs to the surrounding street level. To make it more visible what we do here, I want to create holes, but the fact that buildings are holes are part of the building's geometry. So when I click on this arrow, we get some tabs here. One is called overview, and here we say, okay, exclude from meshes, and you'll see that it has a simply a different icon here, which means exclude. And now I say select geometries, next. We have some general configurations. Here, the snap tolerance 1 meter means that Mesh Builder will shift the mesh nodes slightly back and forth to create an optimal mesh. This is already one of the differences between Mesh Builder and the desktop product. Here, Mesh Builder is more powerful when it comes to optimizing the mesh. The minimum angle is for triangles. I keep the standard 26 degrees and I don't add any information to those two, but I click generate. And this, again, may take some time depending on how heavy the load is on the server, because all this happens online. Right now we are quite quick, that's good. And here we are. So that's the mesh which has been created based on the, configuration. Let's zoom in because I want to show you what happened. I can also use my scroll. Perhaps I switch off the background. You see that the buildings are different from OpenStreetMap. Well, OpenStreetMap is probably not that good because if we include the aerial photograph here, you'll see that the building footprints match the aerial photograph. So I suspect that OpenStreetMap is not that up to date here. You can upload any data. I mean, these red outlines I've downloaded from the New Zealand GIS database. You can use whatever you have or want. You can even extract OpenStreetMap directly in the Mesh Builder. I'll show you in a second. Okay, so this is the background, which I wanted to switch off actually. And here you see the mesh on top of the building footprints. And I could even show them as a wireframe. And you see, oh no, it's not so good. Let's keep it as a surface. Well, first of all, you see that adjacent buildings have been aggregated. So buildings which touch directly, and that's good because we don't need extra vertices around the building. But if you look closely, actually there's still some vertices left along the building outlines which are probably not necessary, especially here. I mean, this is very weird because we have many vertices here. But this is also a vertex created by this after this aggregation process. And for example, here, if we zoom in here, you see that this building and this building and this building, they have the gap between those buildings has been bridged by the routine. So this is now one hole in the mesh. And it's not very nice because these lines are oblique. This 1 meter tolerance has also started to exclude some of these fine structures um, um, around the buildings, which I actually want. I don't need these very small parts here, but they are oblique again, which is not very building-like. Arcs have been simplified. If you look here, the red line is the original shape. And giving this tolerance, this has been replaced by larger triangles. If not, we would have many very small triangles because of this very fine arc here. And the desktop version sometimes is not able to resolve these fine arcs, whereas the Mesh Builder Online is. This here, this is a courtyard in this building, and it is a separate mesh. And it depends, again, on your modeling task, whether you need this courtyard or not. If we keep it like that, and we use rain on grid, so we have water falling onto our mesh, this whole or this courtyard acts like a pot, and it will keep the water on place. In reality, this is probably connected to the outside, and water will flow away. In other words, in many applications, you'll want to remove these courtyards. Yeah, and again, some of these very small wall projections here might be irrelevant, so I want to remove them. And this is where simplification comes into the game. When we click here on the buildings, we get several tools connected or used with geometries. One is called Edit Shape, and it allows us to edit shapes. I'm going back to this area where where I was showing you this special building. So there is a simplification here. And if I do so, you'll see that these buildings become more and more simplified. This part here is taken away. However, but that's not very nice looking. Again, you have oblique angles. They don't really look like buildings. Also, adjacent buildings are not connected automatically here. So this interactive simplification is sort of nice, generally speaking, perhaps with other structures, other shapefiles you load, but especially with buildings, it is not very good. Edit geometry is also useful if you want to edit a single object. You can now draw and you can move vertices. I don't do that here, but in principle, you could do that. I want to show you this building. It has a lot of vertices, which are not really necessary. And this is very typical for data sets which have been treated with GIS tools beforehand. This is, you see that quite often because that's part of some pre-processing procedure, but we don't really want that. So simplification also takes away these vertices. But again, this interactive simplification looks powerful, but it's not really good for buildings. Actually, Quick Simplify is the same thing, just without editing. I mean, I can't click on any nodes here, but it does the same. What we want is a new tool. It has been introduced just a week before, which is called Simplify Buildings. Here are a lot of operations. Some of them are similar to GIS tools, some are more specialized, like the Simplify Buildings. Simplify Buildings tries to make these buildings rectangular. And you have you have two parameters to control how edges are removed. You have also two parameters for connecting buildings and another one to remove spikes, which are created during the process. And the tool is based on a paper, I think it's 2 or 3 years old, Building Geometry Simplification for Improving Mesh Quality of Numerical Analysis Model. Here we have the parameters in our interface, and yeah, we do that live. So we use this Simplify Buildings operation. Simplify Buildings. I use a simplification distance of 2 meters, which will reduce the outlines quite a lot. I want a small simplification angle, otherwise these round shapes become very edgy. Snap distance between buildings, I use 1 meter. So any distance larger than 1 meter will still be visible. But if our buildings are closer than 1 meter, they'll be snapped together. And it depends whether you esteem a gap of 1 meter relevant or not relevant for a 2D simulation. And I remove the holes. Spike angle I leave with 30 degrees. So submit operations. And it will create a new geometry, which I should rename to keep track of what I did. So I usually rename it. So it's indeed, simplify building. And my parameters were 2 meters, 10 degrees, 1 meters, 30 degrees. Well, and you see what happened. Red is now the original outline and blue is the new outline. For example, those two buildings have been snapped together. But you see that everything is more rectangular. You don't have any of these oblique lines anymore, which is very nice. So that's, I think, quite a powerful algorithm. Also, the hole has been removed, by the way, here. And yeah, the outline is still quite nice here. So that's the simplified buildings algorithm. And now we create a new mesh based on these simplified buildings. One of the benefits of the mesh builder is that you have several meshes, one beside the other. So it's not just one mesh, you can use several ones. Instead of creating a new one, I duplicate this one. I rename it. So it's mesh. Oh, it's mesh simplified buildings. Not yet. Again, I click on this arrow to get into the other tabs, and here's a configuration tab. And you see, well, the old mesh is based on the original buildings. I delete those. Instead, I add the simplified buildings. Oh, and again, I forgot to mark them as holes. Exclude from meshes. Yeah, sorry for that. Back to the configuration. So I add geometries. I add the buildings. Next. Anything else? No. Okay, that's good. Again, quite quick. I use perhaps a different color here. You have to get used to this menu structure to find, yeah, the right tab. Let's make that gray. So this is the new mesh. And for example, here you have this typical rectangular connection between buildings. You also see that these vertices here have disappeared. They're quite large, the vertices around the buildings, and they are simpler. I think I've created a slide here comparing one or the other data set. Yeah, so this is the original one and this is the simplified one. And if you look at home, you'll see, well, this has been removed. This is simpler. So it's if you want to have a bit of a coarser mesh, this is a very good way to do it. Now we want to add roads, and you could upload roads from a shapefile. What I want to do is I want to extract them from OpenStreetMap. We have here a tool which extracts geometries. I want to extract anything within my extent from OpenStreetMap, and it's the roads I want to extract. And there are some limitations here to make sure it doesn't take too long. It's very quick today. So these light blue lines are the OpenStreetMap roads. And I mean, I've looked at this data set already, and I see this small bridge here I do not need. This is another bridge I do not need. And also this sort of this in-between road is not necessary. So I delete those. We can also try to simplify the streets slightly to reduce the number of edges you see here. Becomes a bit coarser, and then we click create. And we have the roads in our system. I just make that gray. And so I don't have a polygon file with the road width. I want to make the roads finer. A line is not enough. I need to buffer this line. We have a buffer function here with 4 meters on each side. And later I want to create a finer mesh with 1.5 meters triangles within this buffer. We'll also have some issues here where it's a bit slow now, where the buffer meets the outline. I've said beforehand that Mesh Builder is quite good with overlaps of geometries, much more powerful than the desktop version. So here are the buffered streets. And looking at the time, yeah, I'm a bit slow. Well, there's a lot to tell. Mesh Builder is able to deal with these places here where you have overlaps between geometries. Again, a difference to the desktop version, but it will create quite unpleasant triangles. And to prevent issues here, I simply extend my outline, I buffer my extent as we did beforehand. So I buffer this with, what did I do? I think 10 meters. So this is my new extent, and this will work better. So let's create the next mesh. And yeah, I create a duplicate again. And here, here it is. It still looks the same, of course. And we now configure, edit configuration. We now add the roads. And within the roads, we say the maximum length should be 1.5 meters. There are some other parameters I won't talk about right now. Okay, close. And then I say generate. Yeah, I think I didn't forget anything. And let's have a quick look at the slides while this is running here. Okay, it was so fast. Good. Oh no. Yeah, sorry. I didn't exchange the outline, and now we have probably these not so nice edges somewhere. So I didn't replace the extent here. Delete. Add the extent. Perhaps it would have been easier to create a new mesh. Okay. Yeah, that's what I wanted to see. So the streets have a finer resolution. This is important because they are the main flow paths probably later on when we do a 2D modeling. And by adding a few meters here, we don't have any problems with the edges. I want to point out that here is a building. You see here we had an overlap between the street and the building, and Mesh Builder did that very nicely. So the street mesh follows the building outline properly. And now comes the elevation interpolation. Let me add that Mesh Builder is also able to create quadrangular meshes, but I don't show you that on live. It is a bit more sensitive. It's easier to manage overlaps between various geometries with triangles. If you have quadrangular elements, overlaps are a bit more dicey, so it needs a bit of preparation. Okay, last important step is to interpolate the elevations. And instead of using the slides, I go to this mesh we've created here. Go to interpolation, add a new option. We have only one elevation model. So that's the only one I can use. Any settings here? Yes. Because my I won't do a real interpolation. I just take the nearest neighbor for the grid points because that's faster. I'm not sure. I mean, bilinear is certain. Well, let's try. I'm not sure how fast that is. It's the better way of doing it, but it may take some time. Perhaps I can answer a few questions in the meantime. When you create the mesh, is there any rule, recommendation on maximum element area, smallest allowable angle, max node number? I mean, I think if you talk to different people at DHI, they may give you different recommendations. In urban models, at least here in Germany and Austria, they look at very fine differences. So you would usually go below 1 meter. But if you are in the river setting, this is possibly not necessary. So just to be completely sure, the mesh builder and cloud admin can be considered a one-to-one replacement of the mesh generator for offshore and coastal simulations also. Yes, I mean, it can be equally used for offshore and coastal applications. It even has some special meshing options for these. Whether it is a complete replacement of the desktop application is another question. I mean, we still have the desktop version, and many people stick to the desktop version. The development goes into the online version, but I don't think we'll cut off the desktop version very soon. So it's more up to the users to decide whether they save a lot of time using the online version and use this one. So yes, it is equally applicable for coastal and marine environments, but I wouldn't say it is a replacement. I use it, some others use it, but it's not a full replacement yet. Okay, now this is finished. We have the elevation, and I go back to the overview because here I can change how or what is used for coloring. And you see the mesh with the colors. But the real fancy view is the 3D view now. And if I exaggerate here 5 times, you can see this mesh from various angles. It's not always easy to use. Here's the seaside. So you see the shore here. And those are the mountains. I mean, mountains. They look very mountainous, but this is New Zealand coast. Okay, let me see what else do I have on my agenda to show you before we go right into the question and answers. So this was the elevation. Yeah, back to the slides. We've done that. Quality check is good. I'll show you this live. Yeah, that's important. We can always look at other informations like the area. Do we have any very small triangles? And we can also query for small areas here. And there are still some. I can zoom here. So this is somewhere Okay. Well, I don't see any external shapefiles which force this triangle. There's another one. There's another one. I mean, if they are too small, we probably have to increase they are all around the streets. So we may have to increase the triangles, the size of our street network, or do something different. But you can interrogate area, aspect ratio, and things like that to check where the problems or where problematic triangles are in your network. I think that's important too. Inserting a second DM is easy with Mesh Builder. Here is a region lower compared to the original site. Our client has converted this geotiff from AutoCAD. This is the original elevation model, quite coarse, but that's how it is. Or noisy. I wouldn't say coarse, but it's a bit noisy. And when you work with Mesh Builder, it has regions. Whenever you include geometries, shapefiles, Mesh Builder automatically counts them and gives them numbers. The outer polygon here has the number 1, and the special part has the number 0. And then we can assign the interpolation to certain regions. The 0 region, the 1 region, the outer one, uses the original elevation model, and the 0 region here uses the other elevation model. And this way you can combine different elevation models and create a mesh based on different elevation models and using regions. That's quite easy. Also, I want to show you how to stamp rivers into a 2D model if you have to. This is a workflow from our video. You can see the video online. What we need is elevation points, and you see here also elevation points for the cross sections. And if we assign quadrangular elements to this region, the river is a region, and it gets quadrangular elements. Here you see the regions. One is red, one is blue. Then the interpolation is done outside on the general elevation and inside this region based on the cross sections. And the result is this is the 3D view of the overall mesh with this river in the 2D domain. The other option would be to couple 1D and 2D. It depends on your project scope, what way you go. So, summary. The whole concept of Mesh Builder is data-driven modeling. You modify the input data instead of the mesh. Traditionally, you would create a mesh and then see that, oh, here we have issues, let's change vertex per vertex. Or we have to put something into the mesh, like you have seen before, something deeper. Well, we move mesh node by mesh node deeper down. But if something changes in the source data, you have to redo everything. Here, we modify the input data instead of the mesh, and the mesh turns into a mere function of the input data. This is the idea. This is the concept. I mean, there's possibly still a way to go, but I don't have the time to do so. But if I would change something here, for example, if I would change the extent, I can show you quickly. Let's zoom to all, just to something is slow here right now. I'm not sure. Okay, back to my slides. So if you change something in the source data, the mesh can be created with one mouse click. And several meshes you can create several meshes with one mouse click. And Mike Plus has the same approach of data-driven modeling, because data like roughness or infiltration or culverts, they are all an overlay on the mesh. They are not directly linked to the mesh nodes, but you have any shapefile or whatever it is on top of it. And those two only get merged when you start the simulation. Both the shapes constricting the mesh and additional hydraulic data can be used for a data-driven mesh creation. Summary, Mike Mesh Builder advantages. So it has tools for data preparation. It's very powerful in handling lines and polygons. You can use data from OpenStreetMap or even other vendors, especially interesting for the coastal. I didn't show them, but they are for the marine environment. It offers quadrangular elements, creates quite clean crossing areas. Interpolation is possible from different elevation sources. You can visualize mesh quality and find problematic areas. Maintain several mesh variants next to each other and compare them and then choose the best one. And it has a 3D view. This is the Mike Mesh Builder on the web page, and you can also apply for a access to Mesh Builder through this website or write to us. Let me just quickly present the upcoming events. Mike 2024 is coming soon, and we have these 4 release webinars for the different areas. Mike Plus, I think, will be presented both in water and cities and water resources. Click on the links in the PDFs, and then you get to the registration pages. We have 1 webinar left in autumn about hydrological models in 1 month's time. If you have any suggestions for webinars next year, let us know. And with that, thank you very much. If you enjoyed this webinar, please spread the word, and I would be happy if I can welcome you in 1 month's time. Thanks a lot, and goodbye.